Hello all. Today in this video lecture we will see force couple system chapter numerical. So we will read this numerical first. If the resultant moment about point A is 4800 Newton meter clockwise. So see here, this is point A and it is fixed here, and at point A they told us here it is resultant moment is clockwise 4800 Newton meter clockwise, that's why it is positive, and determine the magnitude of F3. So here it is F3 and we will determine magnitude of this force, and F1 is 300 Newton, this is F1, and F2 is 400 Newton. See, F1 is inclined and it makes 30-degree angle with vertical, and F2 is also inclined and it makes 60-degree angle with horizontal. So first of all, understand how we will solve this numerical. What we will do, we will first calculate moment at A equal to 0 and we equate with those moments with this resultant moment, and that way we will calculate this F3. Before that, we will resolve this inclined components. Here F1, so it is resolved like this. See here 30 degree is attached to this force, that why it is F1 cos theta in the sense 30 degree, and here it is F1 sin 30 degree. Now this F2 force will resolve like this, 60 degree here, that's why F2 cos 60 degree, and here F2 sin 60 degree. Here understand that here it is making an angle alpha with horizontal alpha, and this force is F3 force, so it is F3 cos alpha like this, and it is F3 sin alpha. So just understand here what we are observing here. This is F3 force, this is component of this force, this is alpha, this is F3 cos alpha. So, and here they told us that this is 4 5 3, this is alpha, so geometrically this is also alpha. From this what we will write, cos alpha is equal to adjacent side upon hypotenuse. So here adjacent side is 3 and hypotenuse is 5, and sin alpha is equal to opposite side upon hypotenuse. Opposite side is 4 and hypotenuse is 5. So next what we will do, we will take moment at point A equal to 0. So here see this F1 sin 30 degree component is passing through that point A. Passing through that point A, that means like it is not making any perpendicular distance between that particular point and that force, so it is 0. It is passing through that point, that's why it is 0. Now this F1 cos 30 degree is clockwise to that point. Clockwise, that means positive, and force is F1 cos 30 degree, and perpendicular distance between that point and that force is 2 meter. This 2 meter. So here clockwise positive and anti-clockwise negative. So positive F1 cos 30 degree into 2 again. See this F2 cos 60 degree is also passing through that point A, so it is also 0, and this force F2 sin 60 degree, it is also making clockwise rotation through that point. So it is again positive up to sine 60 degree, and distance, perpendicular distance between that force and that point is 2 plus 3 5 meters. So positive up to sine 60 degree into 5. Now this f3 sine alpha. See here, f3 sine alpha is also making clockwise rotation through that point A, and perpendicular distance between that force and that point is also 5 meter. So positive f3 sine alpha into 5. And here what I wrote, sine alpha is nothing but a 4 by 5. So replace this sine alpha with 4 by 5. Now next force is f3 cos alpha. f3 cos alpha is making anti-clockwise rotation through that point. Anti-clockwise, that means minus, and distance between that A point and that force is, perpendicular distance is this 4 meters. So minus f3 cos alpha into 4. And cos alpha is nothing but here 3 by 5. And in numerical they told us that resultant moment about point A is 4800 Newton meter clockwise. So equate this with 4800 clockwise, that means positive, because it is resultant moment and those are all summation of moments. So by this calculation we will calculate this f3. So here f1 is nothing but the 300 Newton. In numerical they gave us, and f2 is 400 Newton. So this f1 is 300 and f2 is 400. So calculate it. 300 into cos 30 degree into 2 into 400 into sine 60 degree into 5 plus f3 into 4 by 5 into 5 minus f3 into 3 by 5 into 4 and equal to 4800. So after solving it in engineering calculus, we will see what is f3 force. Either what we will do, we will solve it step by step, then it will be easy to us. So this 300 cos 30 degree into 2, so cos 30 degree into 2 into 300, it is 519.615 plus this sine 60 degree into 5 into 400, it is 1732.05 plus this 5 get cancelled, 4 f3 minus this 3 into 4, 12 divided by 5, 2.4 F3, and equal to 4800. So this F3 519.615 plus 1732.05 plus 4 into F3 minus 2.4 into F3 equal to 4800. It is 1592.71, 1592.71, and unit, what is unit? See here, all forces are in Newton. See, 300 Newton, 400 Newton. So unit is in Newton because it is force. So F3 is 1592.71 Newton. So why we equate resultant moment? Because see, resultant moment is always equal to that of summation of all moments. So we saw Varignon's theorem, we learned it in our previous lectures also. That's why we equate it, this resultant moment, with summation of all moments at point A, and we calculated F3. For calculation of F3, we resolve forces. How we resolve forces? Just see it. This cos alpha, sin alpha. So geometrically also it is important. So thank you very much.